Hey guys, so this video is about graphing inequalities. So we've got two types. We've got graphing inequalities that are just already set up for us, and then we've got a couple that you have to solve. So we'll only spend a few minutes on the ones at the bottom here. When you need to solve them though, if you haven't watched the video or haven't been able to solve a linear equation yet, you really need to go there. So if we're not solving an inequality, if it's already solved for us, we're going to make a number line as best you can. It's hard to write on this thing. And we're going to put two numbers on the number line. We're going to put our number, and then we're going to put 0. And 0 is more of a placeholder. It's not really part of the problem. It's just saying which way we're doing. Now, some of you guys say that there's like an alligator or Pac-Man, and he eats the larger number. So I think you'd probably tell me that 3 is the bigger number. However, this is a less than symbol. And that's really what I want you to focus on. Not so much which one's bigger, 3 or x, it's just that it's less than. And where are the less numbers? The less numbers are on the left. The greater numbers are on the right. So we have to shade. Any number that's less than 3, something like 2 is less than 3, that's a solution. Like negative 5 is less than 3, that's a solution. There's an infinite number of solutions. Negative 2.99999. Everything that is smaller than 3 will be a solution. So there's not just one answer, there's an infinite number of answers. So we're going to shade to the left to represent all of these answers. So there's a couple ways people do this. Sometimes people will bring it up off the graph and go to the left. I'm not a huge fan of that. I like to do it directly on the line. Now the problem with doing it on the line is if you're using the same color, it's hard to see. If we switch colors, then I can tell that I'm grabbing it. So if you have a colored pencil, that's fine. A lot of times people will just make it squiggly so that I can tell that it's shading to the left. Make sure you put an arrow on the end because it's going forever. Now, at the 3, do we count 3? Is 3 less than 3? No, because 3 is not less than 3. 3 is 3. So we have to make a distinction about whether we want this to be including 3 or not, and we don't. So there's two ways you'll see this done. The way we'll do it in class is we're going to put an open circle for any less than symbol. So if you have a less than or a greater than symbol, no equal to, you're going to have an open circle. So everything to the left of 3 is a solution. And that's it. For our second graph, we're doing is y is greater than 2, so we put 2 on the number line. 0 is on the left because 2 is bigger than 0, and then we're going to say this is a greater than symbol, so the greater than, actually it's greater than or equal to. That's how you read that. This is greater than or equal to. Now some people say it makes a G, like a greater than sign, that's fine, and some people say that the less than makes an L. It does. I have a harder time seeing the G than I do the L, but I see the bottom of the G maybe. But the L definitely makes an L, and this is not an L, just so you know. Anyway, so the greater than or equal to sign. So any numbers that are bigger than 2, that's where we're going to shade. So we're shading like 3. 3 is greater than 2, right? 4 is greater than 2. 1,000 is greater than 2. So all of these numbers on the right are bigger than 2, so we're going to shade to the right. And because 2 is equal to, we're not going to use an open circle, we're going to use a closed filled-in circle. So anytime you have the less than or equal to or the greater than or equal to, we use a closed circle. Now, I'm going to caution you about something that we'll talk about in class, but you don't want to get mixed up. As long as your variable is on the left-hand side of the inequality, these make arrows, sort of. So this arrow points to the left, is a less than, and this arrow points to the right because it's a greater than, and I shade the way that the arrow is pointing. However, that only works when x or y is on the left. If x is on the right, now if you have 0 as your number, I don't care if you put another number on here, and I don't need you to put tick marks between 0 and 2, like 1, 2, 3, because what if I gave you 72? You're not going to put like 0 and 72 with all the tick marks in between. So you can put like 1 if you want, but I don't really mind too much. Now, what are the numbers? This is a greater than or equal to symbol. However, x is on the right side. It's not saying that x is greater than or equal to. If I were to flip this around, I have to preserve which one needs to be eaten. If you're talking about like the little rabid crocodile or whatever, it looks like a snake. So it wants to eat the larger number, right? So 0 is on the greater side. So if you flip this around, x is actually on the left. Think about plugging in a number. Is 0 greater than or equal to, let's say, what's a number that 0 is greater than? Negative 1. So where's negative 1? Like, this is a true statement. 0 is bigger, right? So negative 1 is on the left. So even though this arrow appears to point to the right, I actually am going to shade to the left. So you can either plug in numbers or just think logically, or you have to switch it around. But if you switch it around, the inequality has to switch as well. You might have a problem with that by saying like, okay, well if I have 5 equals x, and I write x equals 5, I'm not switching around the equal sign. Well, sure, you can think of switching those equal signs around, but that doesn't really do much for us. Actually, let me see if I can do this. This might, oh, no, can't. Never mind. I was trying to rotate it to see if you can see it. I can just move one. Alright, so I'll just leave that alone. Anyway, that's the idea here. So we'll do a couple problems at the bottom, and we have to worry a little bit about negatives, but most of this is just solving and then applying these problems here. Alright, let's do 2 really quick. So in solving equations or inequalities, first goal is to get your variables on one side and your numbers on the other. Now, because of the fact that the arrows work when x, b, y is on the left, I would suggest always moving your numbers to the left, even if they were flipped around and the bigger number was on the right. So we're going to subtract over 4b. 5b minus 4b is 1b, and that should be greater than 5. I don't need to worry about the 1, but I could divide by 1 if I wanted to, but that puts my number line. We have 0 on the left, 5 on the right. Since b is on the left, my arrow is pointing to the right. It's an open circle because there's no equal to in the bottom. Remember that equal to would be a closed circle, and I shade it to the right. Another way to help you remember that the open circle goes with non-equal to, if I had an equal to sign, I would think of filling in the circle with that equal to sign. But since I don't, I have an open circle. Alright, you should try 1 and 3 and see if you get it, and then we'll talk about our negative rule. Alright, so the negative rule is probably the trickiest one you have to be careful of. So you don't want negative x to be less than 4. So to get rid of this negative 1x, you're going to divide by negative 1. Please leave the x alone. I just want to stay where it is. So negative 1 divided by negative 1 is 1x. But here's the problem. Anytime you divide by a negative number, you have to flip your inequality. So if this is a less than symbol, it becomes a greater than. And when you're dividing by negative numbers, there's only one negative here, so it stays negative. So now when I go to graph it, I put my negative 4 on the left, my 0 on the right. It's an open circle because there's no equal to underneath it, and we're shading because the arrow is now pointing to the right, It's also a greater than symbol, and the bigger numbers are on the right. Alright, let me give you a reason why we have to flip this inequality. Now, I think almost everybody could answer the question, 2 is less than 3, correct? Let's eat the bigger number. Now let's multiply both sides by negative 1. So it's a negative 2, and now it's a negative 3. Think about the number line. 0, 1, 2, 3, negative 3, negative 2. Which one's bigger? Negative 2 is bigger because it's farther to right on the number line. You're owing less money. So now all of a sudden, the inequality switches. 2 is closer to 0, but now negative 2 is closer to 0. So be really, really careful. A lot of people forget about this. Alright, let's jump over to number 3. So for number 3, probably the trickiest part is to figure out where do you want to put the x. Because you got to figure out, you're going to put the x on one side, and you're going to put your numbers on the other. Now, there's 2 problems here. When we're solving an equation, we always say that we want to move the smaller one. Now, if we move over the 5x to the other side, it's actually going to make x be on the right, which is a problem for inequalities. When we do an inequality, we usually want x to be on the left. So you get two choices: move the larger number, which violates the rule for solving equations, or move over the smaller number, which violates the rule for inequalities. It really doesn't matter. So in this case, I'm going to move over the 7x just to keep x on the left. I think that that's probably just the easiest way. So subtract your 7x over 5x minus 7x is negative 2x. And then we're going to move the 3 over the other side. So add 3 over. So there's negative 3 on the left. We're going to add 3 over to the right. 3 plus 3 is 6. And then remember, when you divide by a negative number, you have to flip the inequality. So you get x to be less than negative 3. So put our numbers on the number line. Negative 3 is on the left, 0 is on the right, and then we have an open circle. And since our arrow is pointing to the left, we're shading to the left.